All right, so hope we all went through the video because I'm checking every day to see the number of persons that have watched the video. So I'll know those are active. So if at the end of the day you don't have your certificate, just know that it's because you are not active. Because all of this, it has to count. At the end of the day, you have to submit most of the exercises that you are going to have each week. Okay, sorry about that, network. All right, so yesterday we did qualitative analysis, but I'm sure most of you may have the same problem that I'm having. We didn't save it, so we didn't save that particular log view that we did. So I can't find it because generally when you save it, you see it under logout, under layout. You see under layout. So I'll just quickly just do it so that because I still have some few things I want to show on it today. So we have our gamma ray. We have our gamma ray. We have resistivity, RT. We have resistivity, RT. We expand it like that to see. Then we have density. We have density, and then we have compensated neutron lock. We put it here. We can always do so many adjustments here. When you look at these buttons that you have here, you may always size it up. So I can put it like this. You see how it's going to change its shape. I can take it in this manner. It occupies the entire space. Or I can put it like that to feed. Or you can also use your mouse to adjust it anyhow you want. Adjust it anyhow you want. You can always use your mouse to adjust it anyhow you want. You can always use your mouse like that and adjust it anyhow you want it to be. So yesterday we were talking about the cutoff value that we have to use. And I said generally the cutoff value will be the mean value. So for us to get the mean value, if I come here, for example, I click on gamma ray here. If I click on gamma ray here, I'm going to see the statistics of gamma ray. So you can actually see here, this is the minimum value, this is the maximum value, and then the mean value is 100.5. That's the mean value. So we'll actually set this to be 100, which we can just put at 100. So once I click on this baseline, you realize that the information that we have here now is the information of the baseline. If you look up here, we have baseline of gamma ray, because I've clicked on that line. So I can always do adjustment also with the baseline. The cutoff value, I can put it at 100. I can put it at 100. Once I put it at 100, we see what we have there. So I can also look at RT to get the mean value of RT. Once I click on it there, I can see the value. So we have the minimum and the maximum. And then we have the mean value, which is 4.8. So I can also create a baseline here. But remember that the value, the scale here from 0.2 to 2000 is too large. Look at our minimum and our maximum. So what the best scale we are going to use here, in order to put the scale, I'll just click on this line. When I click on it, whatever I have here now represent that. I have the limit. So I'll change this family to user, and then my scale will be from 0.3 to 30, because I said it should not be too far. And remember, I said whatever value we use here, that's the same value that we'll use for this point here. So we see the scale. The scale now, it will be better. Then what else did we arrange? And then we can create a baseline. We can create a baseline here. Insert the vertical baseline. Yes, I click and I just put the baseline anywhere. Then I can click on the baseline. Then I adjust it. The base value was close to about 4.8. That was the minimum, the mean value, about 4.8. We put that so it can now differentiate. between high resistivity and low resistivity. So we can actually see that this area has high resistivity. So we come now to the density. The density, I can reduce the scale, hold control, and I click like that to reduce the scale. I come to the density, that's density there. I said we have to, the difference between the maximum and the minimum, I will take user, the difference between the maximum and the minimum should be 1. So I can take 2.75, and I also, no, 1.75, sorry, not 2.75, 1.75, and here is 2.75. So that's the density. Then I come now to the neutron. I take the neutron value. Also, I do the same. Here we have to change to user. Here we have to invert the axis so that we can see that effect. Then the higher value is 0.6, and the lower value is 0, Then also for the display, we don't want the dashed line, so we are going to take solid lines. So we have it like that. So I will now click on this density. I take control. I click on this to show that whatever I want to do involve the two of them. I will right click, and I will fill the area between the two regions. And I have that field. I click the color. I'm doing it faster because we have already done it. I click the color, and I want to fill only the region that pertains to the reservoir. So I will take the left side of filling. Yes, I take the left side. I may change the color to maybe dark, like that. And that's what we had yesterday. That's a summary of what we had yesterday. So what I will quickly do now is I will identify my reservoirs. What I will quickly do is I'll identify my reservoirs. Hold on, I'm looking for a pen. All right, so someone should give us this value. So the easiest way to pick the reservoirs is I will pick this here. I take this. Once I click here, I can always pick the value. I can hold it and take it up, down, so that I can pick the top and the bottom of this reservoir. So the top is 9,100. The top is 9,100. Is someone noting? Zero, are you there?
Yes.
All right,
Yes.
note.
Yes, I'm noting.
All right, 9,100, the top. And then the bottom, we have 9,212. Let's just leave it like that. Let's forget the decimal. 9,212. All right, we go down now to the second reservoir. We have 9,362. Then the base is 9,415. All right. What was the first value, please?
9,100.
Okay,
100.
9,100, and the base?
9,212.
9,212.
No. The base, I just took all of this as one. Let's separate. Anyway, let's leave it like that. The most important thing is to understand the idea. So what I will do now is I will come to data. I will come to data. I will take zone editor. This zone appears here. What I will do now is they are asking me now for the log that I want to edit the zone. Please drop your wells here. I will carry exa1 and I will drop it here. Once I carry the exa1, I drop it here. I see the value there. I now go to, I click on this here to add new zone. I will just call it R1 for reservoir 1, and I'll take OK. And then I'll click again to add another zone. Since I have two reservoirs, I'll just take R2 and I'll take OK. So it depends on what you have picked. So give me the value of that reservoir 1 top. I'll click here now. I'll double click here and I put the value 9,000.
100.
9,100. I click down. What's the base?
9,212.
212. All right. I go to reservoir 2, the top.
9,252.
9,252.
9,362.
All right.
362.
All right. 300. All right. And then the base.
Okay.
9,000.
9,415.
415. All right. So what I will do now is I'll save it. I'll click on this other button now, the first button here to save, and I'll just give a name to it as reservoirs. I will just give a name to it as reservoirs. I'll give a name to it as reservoirs, and I take OK. Once I've done that, I can close it up here. I can close it. I can close the window up here. I close it. I'm back here. And then I come back now to this first page. What I see down here is project browser. Then the next one is zonation. The next one is zonation. So I will click on zonation. I'll click on zonation. Then on the depth track, I will right click there and I will take yes, insert zonation track. I will right click and I take insert zonation track. The new zone will be formed. Amanda, what are you doing? Awanda, what are you doing? You are doing something that is affecting us here, please. So once I click on this depth track, I take this insert zonation track, this appears. Once this appears, remember that for this side, we have our project browser, and then the next one is zonation. I will click here and I'll see the zones and I'll take reservoirs. Once I take reservoir, the reservoir now appears on that zonation track. I now see the two reservoirs. Once I toggle them on, I see how the reservoirs appear there. I see this as reservoir R1 and this is R2. We may not have picked them well, but it doesn't really matter. The most important thing is for you to understand it. Once, even if you have made a mistake here, you can still go back to the zone and then you edit it. There's still no problem. You can go to the zone editor and you edit that value. There's no problem there. So once you toggle these two on, so I'll take it again. We have our project browser here. I have zonation. I will toggle this down and I choose reservoirs. The two reservoirs appear and it appears on the zonation track. I toggle the two reservoirs on. Then I see the two reservoirs appearing. I can reduce the scale. So this is what we call qualitative analysis. So if you're writing a project, this is exactly what you have to first of all show for your qualitative analysis and explain it well so that they understand what type of rock you have, what type of fluid you expect in the reservoir, and what type of hydrocarbon you have. So this is what we call qualitative analysis. Once you have done this, I've already explained how to get the baseline values. I've already explained how, so I can go back to my project editor. I've already explained how to get the baseline values. So what I will do now is I may now export it. I explained how to export that yesterday. You may export it in the form of PDF. I take prints. Now I go to printer properties and I take Microsoft Prints to PDF and I take prints. So we explained this yesterday. So I want to save this layout here so that anytime I come, I can also open it. So you just attempt to close it. Let's see, you attempt to close it. That is it up there, not the main window. If you close the main big one up, you are closing the techlog. But we want to close but this window. So I will close it and they will ask me save unknown layout. I'll take yes. Selected name. I may just write there qualitative qualitative analysis. Qualitative analysis. Then I will take okay. It has gone, but when I come under layout, I will see it. If I toggle layout down, that's the qualitative analysis there. Anytime I double click on it, it appears. If I want to do any work on it, I can just do it. But if you close the third log without doing this, you come back, you will not see this. You need to start it back afresh. All right. So that's a little thing that was left for qualitative analysis yesterday. Let's go ahead with quantitative analysis. So for quantitative analysis, we are going to go to petrophysics. We want to calculate the volume of shale. We want to calculate the porosity, and then we want to calculate the permeability. We want to know what type of lithology. We want to confirm. We may have identified under qualitative analysis that we have reservoir rocks, but we want to confirm what type of lithology we have there. Is it sandstone or is it carbonate that we have there? We have to do the lithology computation. So we'll do all of that here, and then we can also do the summary to be able to get the net to gross ratio. The net to gross is an important aspect that has to be used in calculating the volumetric quantity of hydrocarbon within the reservoir. So the first thing we will do if we want to get to this is we may go to help. We will click on the help button. We'll click on the help button. I want to show us where we can get the formulas for all of these because we are just going to be doing the calculations. The software will calculate, but you can always get the formula. While the help button is coming, one thing that we must have in order to calculate porosity is a temperature, log. Most of the time, the company may also carry a temperature log, but if the temperature log is not available, we can estimate the temperature log. So what we are going to do, okay, the help button is here. So let me just show what I wanted to show. I may just write there volume of shale. I may just write there, for example, volume of shale. If I write the volume of shale and I click enter, it calculates. I may come here to compute volume of shale. Volume of shale, let me see that. Okay, once you open this, the main thing is to come to what you see here, quantity. That's what we are looking for, quantity. Once you come to this quantity, you click the quantity. It will now tell you what you have to, the various calculations that you have. Volume of shale from gamma ray. I click it like that. So this is exactly the formula that is used to calculate volume of shale. The volume of shale is calculated first by obtaining the gamma ray index. Once you obtain the gamma ray index, you can now apply any correction to the gamma ray index because this gamma ray index is linear. In a situation where the rocks are homogeneous, they follow a linear pattern, but generally in life, they are not homogeneous. So you have to do some kind of correction. The correction now will give us the exact value of volume of shale. The volume of shale is the amount of shale that is found within the formation. The higher the volume of shale, the more disadvantageous it is for the company because they always want the volume of shale to be lower because the amount of shale also goes into block some of the pore spaces and stop the hydrocarbons from flowing. So generally, you might use, if you are working in the Niger Delta, you use the Larinoff tertiary rocks method to calculate the actual volume of shale, because the rocks in the Niger Delta are tertiary of age, even in the Red Basin in Cameroon. So you have to determine this method, whatever method you use here will depend on the age of the rocks in that particular basin. So you have to do that to calculate whatsoever thing, the volume of shale from neutron density. That's the formula there. Everything has been defined in that formula. Everything has been defined. So you can use this to calculate everything. So we can also check for water saturation. We can also check for water saturation. Maybe so we have different methods here. We have the Indonesian, modified Smandov. There are so many methods that you can use. For example, the Indonesian, that is the actual formula that is used to calculate the water saturation using the Indonesian method. You can also calculate the bulk volume water. The bulk volume water effective. The bulk volume water E is for the effective pore space because we have the effective porosity and we have the total porosity. The effective porosity generally is lower than the total porosity because we may have some pore spaces that are not interconnected. For effective porosity, we are interested in pore spaces that are interconnected. So generally, it is lower than total porosity. So you can get any formula from here. So having said that, we want to now get the temperature log because we need that to calculate porosity and water saturation. So what we'll do is we come to pre-computations. When we come to pre-computations, we toggle it down. We take formation temperature. The first one is formation temperature. That's what we have. What we need in that formation temperature is just the depth. It's just the depth. So I will take create. I will take create. All right, it opens this page, but I have to indicate which log I am using to calculate that, because the fact that you want to calculate does not mean that the system has to automatically choose a log for you, because you may have a situation where you have inputted so many logs, so you have to choose which of them you want to use. So I'll take exa1 and I drop it here. Once I drop it there, I now see all of this indication. So you have inputs. The main thing there is this parameter. What are you changing? So we have the top and the bottom. We have the temperature method. Which method do you want to use? Do you want to use a temperature gradient? You want to use a temperature gradient, or you want to use a the TL1 slash BL1 method? Well, that method, I don't think I'm familiar with that. But we have the temperature gradient. I'm familiar with that. So you have to probably, if you're working in a particular basin, you have to get some articles to know actually what the temperature gradient is in that particular basin. So in this case, let's just leave it like that, 0.03. We just use a default value. And then we have the temperature unit is the degree centigrade per meter, degree centigrade per meter. So you can always change the unit. You can always change them. There are so many units there. It could be per 100 foot, it could be per meter, or so whatsoever. So it depends on what you're using. So since we are not using this guy, we are not interested in that guy. We are not using them, so we are not interested in that. So what you do now is there are two various ways in which you want to produce this result. You may want to display it only without calculating. You may want to save the calculation, or you may want to save the calculation and display it. But I think we just have to save it. We are not interested in displaying it. Displaying it means that it's going to appear in the log format. So let's not go into that. So we just click on the play button here. Once you click on the play button, the temperature log has been calculated. I think if you come under exa1, you should be able to see it. That is it, that formation temperature that has appeared. That's formation temperature that has appeared. So we can just close this. Once you click on, if you choose save and display, it will save it, then it will display. But we don't want to take so much time on that. No, there's no, we don't need to go into this. So we close that. All right. Now we want to now start our calculation. We will start with volume of shale. What method do you want to use? Do you want to use a single method or a double method? Whichever method you choose to use, you can always get the formula. I've shown how to get the formula, but it's always advisable to use at least maybe two methods to see how you can compare them. So what I'll do here is I can just take gamma ray method, but you can also calculate it using the neutron density method. You can, if you have the potassium log, the thorium log, you can use it. Neutron sonic, you can always use them, but the most effective is gamma ray and neutron density. But gamma ray is one of the most effective. So once you have chosen gamma ray, you may have to choose a gamma ray log that you have. I will just take this blue one here. Once you take the blue one here, once you take, you realize that you have different options here. Once I take the blue one, so many things appear. If you don't see it here, you might still take this green. You still see it there, there's still no problem. So if I take this, what they need here is the gamma ray. So I will click on gamma ray and I click this arrow and it enters there. If you have anything like the gamma ray matrix, you can include. If you have anything like the gamma ray shale, you can include, but these logs are not available. That's why they have, you see it is a little bit darker. That means it's optional. But this one, if you don't put this one, nothing will go because it is in white. You must put it. So once I take create, it appears like what we have already seen. I will now choose the well that I want to do the calculation on, and I display it there. The well appear. Remember that our first thing is to the parameter. The parameter are the most important thing that we want to calculate on. So now we have the gamma ray matrix. They have given us the gamma ray matrix and the gamma ray shield. The gamma ray matrix is the lowest value of gamma ray, and the gamma ray shield is probably the Shale baseline. The Shale baseline, and that's the lowest line. So these values, you can always correct them. Correct them based on probably the highest and the lowest value. I think we'll use the highest and the lowest value. So the lowest value here is, let's say, 12.8. So let's not overcomplicate it. Let's just say 13. We put it there. And the highest value there, and the highest value is 146. Let's just put it like that. 146. You have to indicate all these values. 146. Then you have to choose the method, the gamma ray method. Remember, we said we don't want it to be linear because linear is not the right value. So we have to do the correction. So we have to do maybe Larinoff tertiary, whatsoever. We take Larinoff tertiary. Down here, we take Larinoff tertiary. Then we have to choose now what we want to do. So in this case, I would like to save and display so that we also see the log. Save and display. Once you click on calculation, that's it, that it appears there. If you come here, you will now see that the log has been created. It's so unfortunate that in this case, the log that we inputted already had volume of shale, but generally it will not have it. So this is what we have calculated. The one that the log came with, we can even delete it because we have to do our own calculation. But generally we will not have this. So this is what we have calculated. This one came with the log. I think we made a mistake. We would have deleted it at the beginning, but there's still no problem. So this is now your gamma ray. This is what you have to now start showing. That's what you have to show. So this is telling us, you can see from the plot up, you realize that when it becomes darker, it means that the gamma ray value, the volume of shale is increasing. So this tells us that this area here has low volume of shale because the color is a little bit light. This area has low volume of shale and all of that. All of these two sides, you may like to maybe, this is the gamma ray log. You may like to delete the track. There's no problem there. If you don't want to indicate this one, you may want to delete it. You may want to delete the track. I delete it. You may want to delete this track also. You delete it. So you now see the gamma ray log, and then you see the volume of shale from gamma ray. You see the volume of shale from gamma ray. You now tell us exactly. I can still control hold and squeeze. So you can see it that this area has very high volume of shale, then this area has low volume of shale. You may also want to probably use a cutoff value. We may probably want to use a cutoff value. So what I will do now is I may include a baseline, insert a baseline. So I may insert a baseline here. So you may want to use a cutoff value. I think this baseline, no problem. We can still carry it there and we put it there. So that's a gamma ray. So in this case, you cannot use a baseline when you're using this. If you want to use a baseline, then you have to eliminate this color. You have to eliminate this palette. You have to eliminate this palette. If you want to use a baseline, then you have to eliminate that palette. So you have to eliminate it and probably choose, let me see if, okay, you see here, it's palette. So you can change it into a color. You can change it into a color. So if you want to put a baseline there, you have to remove that palette. All right, so that is volume of shale from gamma ray. So you can actually see that this area has low volume of shale. This area has high volume of shale. I also want to close it so that they'll ask me if I want to save it. I said yes. And then I will now just say VSH, and I take OK. It has been saved under layout. That is it, the VSH under layout. I may just close this guy. No, I may just close that guy. So I've calculated volume of shale. What's the next thing? The difference between techlog, what I've seen with techlog and other softwares like IP, is that techlog is unique in a certain aspect. Techlog calculates the total porosity and the total water saturation in the total pore space. It calculates the effective porosity and the total water saturation in the effective pore space. So there are two types of water saturation that is calculated here. In the other case, they just calculate maybe effective water saturation. They don't even tell you, like IP, interactive petrophysics, will not even tell you that. But this one is telling you exactly what you're calculating. Is it total water saturation or effective water saturation? They have given the various methods that you have to use. I can come under porosity here. I look at it. Total porosity, effective porosity. I see the various methods. I can come under saturation here. You see the total porosity saturation. They have given you the various formulas that will give you the total porosity saturation. They have also given you the various formulas that can be used to calculate effective porosity saturation. It means that if you are actually using maybe the Indonesian or the Simandov or the modified Simandov, what you're calculating is the effective porosity saturation. But if you are using oil water, it means that what you're calculating is total porosity saturation. So there may be a big difference between them. So I will just come here. Let me take a total porosity and saturation. Maybe I just take from density or density neutron, whichever method you want to use. So I'll take maybe from density. It means that I need the density log and I need the temperature log. So if you do not calculate the temperature log, if you do not calculate the temperature log, you will not see this guy here. So I just click on the temperature and I click there. So once the temperature log is not available, there's no way you can do the calculation. So what I'm calculating now is the total porosity and the water saturation in the total pore space. So I'll just take create. I'll just take create. I carry the log. I carry the log and I drop it there. Oh, they are telling us that there's something that is not available. Okay. Once this log does not have something that it needs, it will not go. So if I take this, let me calculate from, okay, let me first
It's
of all
running some
calculate the
down here.
porosity. Let's calculate the porosity from density log first. Let's calculate the total porosity from density log. So I will take density log. That's the density log that appears there. I will take create. I will carry and drop. So I go to parameters. Okay, they have given us the parameters here. There's nothing more to indicate there. You go now to save or save and display, whatsoever, save and display, and you take that. So it gives you so many things that you can even delete the ones that you don't need. But the most important thing is, what is the total porosity? That's where our interest in. The things are so choked up. Let me, so choked up in such a way that I am not even still, I'm not seeing. All right, if you look clearly, this is our porosity track. This is our porosity track. This is our porosity track. The field is from 0 to 1. So this is 0 and this is 1. So it means that when it has this value, this blue kind of coloration, it means that the porosity is high in that particular zone. It means that the porosity is high in that particular zone. We are going to illustrate all of them, but let's do the other calculation first. I think, okay, yes, we may save it. Yes. All right, so I may just say total porosity. I may just say total porosity. So you can always expand and see the things well, total poro. All right, I'll close this. You want to know. Then I'll go there again. Then I go now to the saturation and I will calculate total porosity saturation. Since I've already calculated total porosity, can now calculate the total porosity saturation. We have the formation resistivity, we have the porosity, then we have the shale volume. The porosity is already there. No, let me see. All right. All right. So what we need, this one came with the log. this porosity effective came with the log, we would have deleted it. This is what it has calculated. That's what we need to calculate total porosity saturation. This is total porosity from density. So I will put it here for porosity. That's what I will put there for porosity. Volume of shale, I will choose the one that we calculated. Volume of shale from gamma ray, that's what we calculated. And that's what we have. Then we can now take create. Then we carry the log and we put it there. Everything appears. We go to parameter. Is there any adjustment here? No, there's no adjustment here. So I will take save or save and display. I take save and display. Once I play it, so many things appeared, and I have to expand it to see the various things. All of this one like this, you can delete all of this so that you see these things clearly. So let me see. All right, you expand it like that, and maybe we can see it clearly. Oh, let me see to fit. Voila. So I can fit it there. So that, okay, this is dual water. That's porosity. Okay, this is water saturation. That's water saturation from total water saturation. That is it there. Once you delete all of these things, you see it clearly. Once you delete this ones, you see it clearly. That's the water saturation from dual, the dual water saturation. That is it there. So you can always see all of these things clearly. I have said the ones you don't need, even this, we don't need all of this. We remove all of it. One thing the software is doing is that everything that you have chosen as an input, once you click on display, that what you have chosen as an input automatically becomes part of the display. That's why you see so many things there. So you may that all of these things may not be what you want to show. You want to show the water saturation. So what I will do is I delete the things that I don't need so that I can see what I need very clearly. So I will close it there. Then I take yes. Then I may just write there water saturation. Water sat. All right. It has been saved. I can close it. No. So I've calculated the water saturation, the total porosity, and the total porosity saturation. So you can also calculate the effective porosity and the effective porosity saturation. You can always calculate all of these things. Remember that once you do the calculation, it appears here. It appears here. So even if at the end of the day, you don't need that plot that you did, I may just come to plot. I choose layout. I may just come here. I want to show maybe the total porosity. I carry it here. I put there. That's the total porosity. I take also the water saturation. I take the water saturation. I put it there. That is it there. I can reduce all of these, the sizes. I can reduce all of them. I can reduce the scale. I can reduce the scale so that you see it better. I can reduce the scale so that you see it better. I may also want to put SXO is the water saturation of the flush zone. I may also want to show it. That's the water saturation in the flush zone. So you may not even need the plot. That's the first plot that we have. If you are not seeing things clearly, you come here, you have done the calculation, you pick them and put them here, you see them all. You may now have to arrange it. You may want to maybe arrange the scale. Let's see what the scale is. Maybe it's appearing like this because the scale is not okay. I will go to user. I will take okay from zero to that. All right, so it appears like that. So I may want to resolution, single color. Okay, all right. So there are so many things that you can do there. So I will not go dangle into, because we have a lot to do, I will not dangle into calculating the effective porosity. I will not dangle into that because we already have shown how to calculate that. What I will instead do now is I will go now to probably the lithology. I will take lithology. I may take lithology computation. You may take neutron density. You may want to take this lithology from porosity, or you take porosity from lithology. So let's take this lithology computation here. They have asked so many things: the bulk density, the water saturation, the shale volume, and the effective porosity. All of these things we are assuming that we have calculated. So can you hear me?
Yes, sir.
All right. So all of these things we have calculated all of these things. So I will just click create, then I carry the log. I carry the log and I drop it there. All right, I carry the log and I drop it there. So there are so many things that you will not. So I may want to maybe save and display. So I display it and I see so many plots coming out and I have to choose what I want. This guy, I don't need this guy again. I don't need this guy. This one, the components are not there. That's why you see all of this is not appearing. The components that is needed are not there. So we don't need this one. No. All right, so we can actually see this. The points are not plotted. That's what I'm looking at. Let's see. Once you control and hold it and drag, you can see the various domains of that particular plot. So I'm looking at y apparent matrix density and apparent matrix. Okay, we don't have the photoelectric factor. We don't have the photoelectric factor. So that one also is not available. So we cannot produce that. We don't have the photoelectric factor. So what we can do now is, let's take the second option. We have this. All right. So we drag this and we put borehole temperature for the meter 1 or more. I'm missing for the data set. Anyway, what I can just easily plot the thing by coming to plot. I take cross plot, it appears. If I want to draw the neutron density cross plot, I will take neutron value, compensated neutron log. I put on the y-axis. I take the density rho b. I take the density, the
Density is supposed to be on the Y instead.
axis. Then I will come now to this option. There's an option here. We have charts. I will come now to charts and I will choose which plot I want to overlay there. We have so many plots, so many of them produced by Schlumberger, Halliburton, and all of that. So I may take Schlumberger, neutron porosity block. There are so many of them. So once I double click on it, it appears there. I can hold the mouse and drag, and then you now see exactly. I think it was supposed to be density on the, but there's still no problem. So you look at the lines. This is the dolomite line. This is a dolomite line. This is limestone, and then this is sandstone. This is sandstone. So we can actually switch the axis. We can switch the axis. We can delete this. We delete this. So we put density down here. I think it will show clearer. We put density down there and we put compensated neutron log maybe up there. And then we go now to chart and we take any of the chart. All right. So that's the dolomite up there. That's the limestone and all of that. So I may now want to probably plot it for the various zone. I will come here, I choose my reservoirs, then I will now take reservoir 1. Once you have taken reservoir 1, it has plotted only for reservoir 1. So this is already telling us, because this middle line is a limestone, this is dolomite, this is limestone, and this is sandstone. So this is telling us that the lithology in that particular basin is the limestone basin. So if you're saying that it is sandstone, then you come here and your plot is showing that it is limestone, then there's a problem somewhere. Because if it was sandstone, most of the points would have plotted around this particular zone. So it's showing us that the lithology is what? is limestone. So you can always plot the density neutron cross plot to show the type of lithology that you have. The other ones did not come out because we don't have the components that are required. We need photoelectric factor. I'm not even too sure if this thing has sonic. I don't know. It does have sonic also. This one also does not have sonic. So it's a problem. That's the reason why those plots do not come out, because generally a log should have sonic, but it must not have photo. This one has photoelectric factor. The problem was sonic. This particular one has photoelectric factor, that is it, PEF. But the problem there was sonic. That's the reason why it could not come out. Then what else can we do? I think that's basically the idea about petrophysical analysis. Then you can now calculate the permeability. There are two ways here. We have the Wiley-Rose and we have the Quartes equation. So you can choose any of them. I've shown how to get the formula. Once you choose any of them, you go to the formula. You can always pick the formula. So this one requires what? It requires total porosity and effective porosity. It requires total porosity and effective porosity. So in this case, we'll just use this one. Even though we did not calculate it, we'll just use that. And we take, yes. Then we carry the log. You must always carry the log and you drop it there. Once you carry the log, you go to parameters and see if there's any zone. Okay. When it comes to quarters, it's very complicated to calculate it using the quarters, because the quarters has different formula for the clean zone, and different formula for a dirty zone. We have the low porosity zone. So quarters has a different formula for the clean zone and a different formula for the dirty zone. So it's very complicated to use quarters, because you have to identify unless you're calculating. Okay, I think my network failed me. But if we are still there, so what I was explaining is that for this is probably tough, because you have to identify the various zone to say which one is clean and dirty. And since we are dealing with zones that we have dirty and clean, is probably this one method is very complicated, unless you have to identify just that depth in which you want to calculate, because I've given the top and the bottom depth. You may want to calculate it only for reservoir 1 or reservoir 2. So you have to give that top depth and the bottom depth. So I think that would be a better solution if you have to use this particular method. All right. So I think that's basically the idea about quantitative analysis. The only thing that is lacking now is how do you bring out the net to gross. So the net to gross, you come to summaries. You take summary. What is needed? We have volume of shale, we have porosity, we have water saturation. All of this, if the company has, they will have to use it. But if they don't have, there is no problem. So we have to create that. I will pick this and I put there. So you have to go to the parameters and look at the parameters. Volume of shale minimum. All right. So generally, for you to calculate what we call the net to gross, you have to identify the cutoff. Now, every company will have their own value for cutoff. They may say if a particular reservoir has a volume of shale of, let's say, 0.5 and above, then that reservoir is not good enough for us to work on, unless we have to use some kind of sophisticated method. So they'll have to define the cutoff value for the volume of shale. Here, the default value is 0.5, but this may just be only in a case where that particular basin is very dirty. If you are dealing with a basin that has very good sandstones or carbonate rocks, then our cutoff value could be 0.3. We put our cutoff value to be 0.3. We put our cutoff value to be 0.3. After putting that cutoff value, you have to define where a better value is. For example, the value that you want, is it in between the maximum and the minimum or whatsoever? So you have to define all of that. So in this case, we say the value is greater than or equal to minimum and the value is less than minimum. And in this case also, the value should be greater than or equal to the minimum, and the value should be less than the maximum. So you are telling the software that my preferred range is between 0 and 0.3. That's your preferred range. Anything outside 0.3, it is not a good value for me. So that's what you're telling the software. You now come also to water saturation. They may use porosity. Porosity could be not from 0. They may use, because a porosity of maybe 0. or 10% may be too poor. So the lowest value of porosity, you may say 0.1. You may say 0.1 for the lowest value of porosity, 0.1. Then for the highest value, we would hardly have a porosity that is above 0.5. So changing this to 1 also will not change anything. Then you have to also define your boundary. The value that you need are the good values are those values that lies between the minimum and the maximum. Then you also define your water saturation. 0 to this value is too high. A water saturation of above 0.6, I think you have a lot of water production, and I think the well will be abandoned. So we might just say our maximum water saturation is 0.6. That means anything outside 0.6, we don't need it. So we have also defined our range then. Then I will just, first of all, then they may say the flag. What do you want to calculate? Do you need just for the pay zone? Do you need just the parameters for the pay zone, the parameters for the reservoirs and the rock, or whatsoever, and all of that? So this is telling us that if you're talking about rock, reservoir, and pay, you are using volume of shale cut off, because the volume of shale, since we are using gamma ray, will tell us if it is reservoir rock or non-reservoir rock. That's where this rock flag will come from. Then it will also give us a good idea about the reservoir also. And then it will tell us if it's a pay zone. When it comes to porosity cutoff, we don't need the porosity cutoff for rock type. So for rock type, the volume of shale is sufficient enough. Then for porosity cutoff, for reservoir and pay, we are going to need the porosity cutoff, because once the porosity is too low, it is not a good reservoir. You cannot call it a reservoir. Then for water saturation cutoff, we need this water saturation only to calculate our pay value. Only to calculate our pay value. That's where we need the water saturation. So we'll leave all of this flag, but you may choose to eliminate anyone you don't want to calculate. If you want to eliminate, you can always eliminate them. You can always eliminate the ones that you don't want to calculate. So for here, we don't have any result yet. So I would just want to save the result. I don't want to display it yet. So I will click on this. I want to save the result. All right, let me see. All right, no results yet. All right, so this is our results that we have for the two reservoirs. That's the result that we have for the two reservoirs. So we have, you can see your gross thickness. You can see your gross thickness. You realize that for each reservoir, you have 3 parameters: for the rock, for the reservoir, and for the pay. Then you have the net to gross for the rock, for the reservoir, and the pay. Then you have your net to gross thickness. This is the most important. You realize that for the pay, the net to gross is 0.2, which is very, very low. This is where our interest in. And then they also calculate all the various parameters in those various intervals. So you can tell someone the average volume of shale in that particular reservoir, the average porosity in that particular reservoir, the average water saturation in that particular reservoir. This statistics is what you have to actually give at the end of the day in the form of a table, because a quantitative analysis means that you're actually calculating the parameters, some kind of parameters in the reservoir. So this tells us about, this gives us a lot of information. The most important is what? Is a net to gross. Then we have the bulk volume water. The bulk volume water here is just water saturation times porosity. We have the average volume of shale, we have the average porosity, and we have the average water saturation for each of the reservoirs. So this now becomes our good value, the values that you have to actually represent and you submit as the final quantitative analysis. All right, so from there,